Let's do some order of operations. So as you are undoubtedly familiar, the order of operations is parentheses first, then exponents, then multiplications and divisions, and then additions and subtractions. All of them from left to right. So now there's one extra addition on this particular problem right here, and that is that we have one big fraction. Okay, so when you have a big fraction, what you're going to do is just simplify the top according to the order of operations all by itself, and then simplify the bottom according to the order of operations all by itself. Once both of those things are done, we can combine the top and the bottom via division. So it looks like this. On top, are there any parentheses? Yes, there are. Therefore, I will work inside the parentheses first. Inside the parentheses, are there any exponents? No. Inside the parentheses, are there any multiplications or divisions? No. Are there any additions or subtractions? Yes. So I evaluate the addition, or well, the subtraction. And I get 8. I could keep the parentheses around the 8, but I don't need to because it is now just a single number. Let's finish simplifying the numerator, the top. There's only one thing left to do, and that is square the 8. But I'll go through the order of operations again for practice sake. Are there any parentheses on top? No, not at this point. Are there any exponents? Yes. So I will evaluate the exponent. 8 squared is 64. The top is now completely simplified. Now it is time to explore the bottom. So in the bottom, are there any parentheses? No. Are there any exponents? No. Are there any multiplications or divisions? Yes. So I'll evaluate them. 2 times 9 is 18. We left off with multiplications and divisions, so the next question is, are there any additions or subtractions? Yes, there is this subtraction. And 18 minus 2 is 16. Now that the numerator and denominator are both completely simplified, I can combine them. 64 divided by 16 is 4. And the problem is done. Let's quickly see how to handle this. It says that everything inside the parentheses is being raised to the third power. Therefore, the 5 is being raised to the third power, and so is the 3 in the bottom being raised to the third power. 5 times 5 times 5 is 125. And 3 times 3 times 3 is 27. And since nothing cancels, the fraction is already in simplest form. And there it is. Now let's find the perimeter of a square. The first thing we need to realize is that it is a square. And something that we know about squares is that all 4 sides are the same length. Therefore, each one has a length of 15 meters. The other important thing to recognize is that we are looking for perimeter. Perimeter is not the amount of area inside, that would be base times height. Instead, it will be the distance around the edge. Well, I could say 15 plus 15 plus 15 plus 15, but we're in college, so let's just say I've got 4 15s, and 4 times 15 is 60. 60 meters is how far you would walk if you were to go all the way around. Now we will do area of a square. Again, since it is a square, we know that each side is length 8 meters. But this time we are looking for area. So we are not looking for the distance around the edge. Rather, we are looking for how much space there is inside. Well, that space has certain dimensions associated with it. It's 8 meters that way, and it's 8 meters that way. Therefore, the area of the square found by multiplying base and height would be 8 meters times 8 meters. And 8 times 8 is 64. And m times m is m squared, or square meters. That's consistent with what we see in the real world. For example, when you purchase a home, you are interested in how many square feet there are in the home, or how much space the floor plan occupies. So that's how it's done. Now, for volume, we just look at the dimensions that define how big the object is. Just like with the square, we said to find the area was defined by the base, or that's not the base, by the base and the height. And so we multiplied those two together. But the volume of this guy here, which is the amount of space inside the box, or in other words, how much stuff you can fit in the box, the volume is defined by how far this distance is, and that distance, and that distance. We have to know all three. Therefore, the volume will be the product of all three. 5 meters times 5 meters times 5 meters, which would be 5 times 5 times 5 is 125, and meters times meters times meters is cubic meters. And so one thing we can get from all of this is when you hear about cubic meters or cubic yards or cubic feet, you know you're talking about volume. When you hear about square feet, square inches, square yards, you know you're talking about area. Now let's do one of these. Kira has D decks of cards. Each deck has 52 cards in it. Using D, write an expression for the total number of cards Kira has. Let's get familiar with this problem first using simpler numbers. So if she had, let's say, one deck of cards, then how many cards would that be? Well, it would be 1 times 52, or 52 cards. If she had 2 decks of cards, how many cards would she have? She would have 2 decks times 52 cards per deck, which is 104 cards, and so on. And I'll do one more. So that is what we get. Well, we still haven't written down what to do yet, but we are getting very close. One thing we could do to help us understand this and future problems that we will see is to recognize that all we've really done is make an input-output table where our x values are on the left. Actually, in this case, our x's are going to be called D, and then we have y values on the right. But typically, over here on the left is called x. So we know that this is how many cards are left over, and we see how that is determined. We can see that whatever D is, we're going to take that number and multiply it by 52. And that will give us how many cards there are. So once again, right over here, take the number that D is and multiply it by 52, and that will give the number of cards. So by writing it out this way, showing my calculations, I can use that sometimes to make it easier to solve certain problems. So this is a technique that you can use to help you out throughout all of algebra. So my formula would be D times 52, or you could just say 52D, it doesn't matter. Either one is fine, because that is what we're doing each time to get this. This is fundamental to understanding all of algebra, so make sure you get this one down really well. Now let's do some more translation, translating a phrase into an algebraic expression. And yes, that was my phone going off. The phrase is 70 less than twice Craig's age. And it says, use the variable C to represent Craig's age. We don't have to use the variable C. We could use the words Craig's age, but then we have to write that out each time, and it's just easier to write C, and that is why we use variables in math. It's a shortcut. So a popular wrong answer to something like this would be 70, subtract, because of the less than, twice Craig's age. I don't know why that's not writing very well. That's not quite right, because let's say that Craig is 50 years old, and if we ignore that for just a moment and just think about this, then we might think, well, if Craig is 50 years old, 70 years old less than twice his age would be twice his age minus 70, which is going to be 30 years old. But that's not what this says to do. What we have over here says to do 70 minus double his age, whereas what we really want to be doing is double his age minus 70. So the correct answer would be 2C minus 70, because that's exactly what I'm doing here. 2 times Craig's age, C, minus 70. One more. On this one, we have 13 more than twice a number. So once again, twice a number is going to be increased by 13. Now with addition, it doesn't matter if the plus 13 comes first or second, because that's how addition is. Doesn't matter the order. However, I like putting the plus 13 second, because then when I do a subtraction problem like the last one, then it helps me to get things in the correct order. So that is how it goes, and that's it.